In this video, I conclude my engine alignment coming up. Hey, how's it, folks, and welcome back. And a special welcome to the new subscribers. Thanks for joining us. So in my previous video, I was establishing, let me try to say that word again, establishing all these lines on the floor, reference lines, so that I could measure for proper engine alignment. Today, I would like to conclude that exercise so I can build my engine mounting brackets. I do need to ensure that my U-joint angles are within acceptable limits. So we'll be looking at that as well. You might hear a little bit of rain on my roof. It's actually quite cold today. It's very strange weather for this time of the year. But nevertheless, I've got lots of energy, so let's get going. Okay, and this one now measures 1101 millimeters. Yes, awesome. I've been crawling around on the floor for quite a bit now. Pushing the engine this way, pushing the engine that way, carrying on to get these two exactly the same. Tape measure in the back from the center line of the output shaft on the gearbox to my reference line. And then of course this one in the front from the center of the crankshaft also to my reference line. I've now got these two measurements exactly the same. Whoopee. So that would mean that my engine center line is now parallel to my reference line. In case you're wondering, I did check these two tape measures against each other to make sure that they do read the same. You'll actually be quite amazed how tape measures can differ. They're not all to the same calibration. I mean, I've seen huge differences between tape measures. Back in the day when we used to build boats, we would all go to the shop together and then buy tape measures by checking them against each other so that we could all have the same measurements. So with those two measurements the same, I now know that my engine center line is perpendicular to the axle. And I've currently got a gap here between the stock manifold and the steering box of about 6 millimeters, quarter of an inch. I do believe that's enough. If I ever want to change the stock manifold and go to a custom header, well then of course you can build it to suit. Okay, so far so good, but now the golden question is this. What is the angle on the U-joint in the back? Is that within acceptable limits? So let's go and measure that. So yeah, it's a bit confusing with all the cross members, but hopefully you can see what I'm trying to show you. So I needed to establish some reference lines for myself so I can measure this angle on the U-joint. So the first thing I did was to clamp this piece of aluminium angle bar onto the prop shaft itself. In American, aluminium would be aluminum. So this gives me the line of the prop shaft. Then I clamped on this straight edge, the ruler here, onto the yoke. It is parallel to the machine surface itself. So now that I've got these two reference lines, I can measure the angle between them. So I've pulled out my trusty old protractor. Little bit rusty, little bit dirty, but it still does the job fine, just like me. So I'm going to now measure this angle best I could and see what I get with this. I'm just lining it up by eye as best as I can. Okay, let me see if I can get the camera to focus on this. And then I will try and hold it as steady as I can. Can you see there? Shall we call it 2.5 degrees? It's a good number, I like that number. So now, I'm sure some of you guys are going to say, well, how accurate can my rusty old protractor be? Okay, we can do the high-tech approach out here in the forest too. My clever daughter has downloaded an app on my phone. Let me show you. Where did it go? There we go. I don't know if you can see this. Check that out. It's like a fancy see-through protractor on top of the picture you see through the viewfinder. How clever is that? So it's got different functions, and one of those functions is a protractor. Check how cool this is. Protractor, excuse my thick fingers, that's what I've got. And now look at that, isn't that awesome? So you can set the thing and measure some angles. It's got the roll and the pitch set you can set up. It's really great. So I'm going to try this on the U-joint. It's freaking impossible to hold the phone steady here to measure those angles. So I've clamped on this piece of plate. So now I can rest my phone on the plate and then line up all my edges so that I can take an accurate measurement. Let me show you a close-up. Right, so the phone is as steady as I can get it. I've lined up my edges nicely and I measure 92.4 degrees. So the U-joint angle is 2.4 degrees. So my trusty old Starrett protractor, this thing has been with me longer than what my wife has been with me. And that's been a long time, so I know it very well. It measured, yes, I can't see, yeah, 92.5 degrees, we said, right? The fancy modern app via my lovely young daughter measured 92.4 degrees. So yeah, this is not bad, eh? I mean, it's only out by 0.1 of a degree. Look, 92.4, 92.5. I think we can safely assume that that U-joint angle is in that region of about 2.5 degrees. So what does it mean? Let's go ask the clever people. To prove I'm not bullshitting you, I went to the Spicer Parts website where I found the basic rules with regards to U-joint angles. And here is the one that I'm currently concerned with. Operating angle should be less than 3 degrees for vibration-free performance. So that means I'm good. Ta-da! Okay, back in here under the truck, I'm by the gearbox mounting. Here's the cross member. So with the engine moved over to the left, this is going to be the new location. So I need to drill a new hole here. I've measured the distance that is moved across, and it measures exactly 46 millimeters if you want to be accurate. What is that in inches? It's a little bit shy of 2 inches. So yeah, it's going to be, the fun now is going to be to drill this hole. I want to drill it in situ, and I've got to drill it through this side and the other side. That's going to be fun, but I'm not going to take the gearbox out or move it up or anything. It's staying right where it is. So let's give it a shot. I'm just going to slide away here on my crawler. That's through the one. I've still got to go through the next one. That's going to be fun because I need to somehow aim and make sure it all lines up. Right, I'm going to aim as carefully as I can, and then we're going to hope for the best. Right, got the 10mm drill bit through. Okay, so here they've got a spacer piece. So I'm just going to have to do something similar. I'm just going to cut a piece of pipe that fits in here. When the only purpose of that really is to prevent the bolt from closing this U-beam. So I'll just cut a piece of pipe that fits in there. Okay, here's my little piece of pipe. The ID is a little bit more than 10 millimeters or 3/8. I bought a length of this tubing quite some time ago, specifically for this kind of application. Yeah, it's proven to be very handy. I also bought the length with an idea of just over 12 millimeters, around half an inch, again for this kind of thing. So yeah, it's very handy to have around. So I'm just going to, there's a nice tight fit here. There we go. The bolt is through. Yeah, of course you never have the right bolt. I'm going to need a longer one and a high tensile one, but at least now it's located, so the back end of my gearbox can't move anymore. Whoopee! It's secure, it ain't going anywhere. Let's get the old prop shaft back into place. Oh, that went nicely. Right, let me get my sorry ass out of here. I got tired of hoisting the engine with a chain block and messing around with blocks underneath to try and center it and position it. It was tipping and carrying on. So I built a sort of temporary cradle here, if I can call it that, to help me. Let me show you quickly. And here's my contraption. The engine is actually resting on these two posts. And I've installed these bolts here. So by turning the bolts I can move the engine up, or you can even tilt it a little bit like this. So once I had this in place, I could now move the engine sideways a little bit until I had it center. I can play with my bolts to level it in that way. I suppose you would call it the pitch. And now I can still take it up and down to set my engine angle, which will be the next thing I want to do. If I turn these bolts in, I lift the engine up some, and vice versa. It's going to make my life a lot easier. It already is. If you like the t-shirt, there's a link in the description. You can buy them online. Different designs, different sizes, different styles. Back to my drawing lying here on the floor. This is the DCAD version now. The dirty cowboy assisted drawing. We are looking at it from the sky, bird's eye view. We're sitting on Mars or somewhere up there. And this is what Mr. Ford designed. Engine and prop shaft offset to the right. What did I gonna do? I moved the engine over that way. I'm exaggerating just so that we can see the effect. What's the implications of that? I've changed the angles on the U-joints there and there. What does the angles measure? Currently about 2.5 degrees. That's the angle between the center line of the engine and the center line of the prop shaft. 2.5 degrees here, 2.5 degrees there. That is completely within the parameters. The clever guys at spicerparts.com say stay under 3 degrees. So I believe we're on target there. Now let's look at this truck when we view it from the side to see what's going to happen there. Here's the side-on view. This point is now been fixed. You can still adjust the engine like that. We can still adjust the differential like that. So what I want to achieve now is to line all three of these components. Have them lined up as well as possible so that there's actually no angle change on these U-joints whatsoever. So yeah, most guys would say that is not the way to do it. It's incorrect. You should have some kind of an angle change, something approximately like that. Yes, I agree on a typical instances, but remember one thing, looking from the top down, I've already got an angle change on the U-joints. You do want an angle change of some sorts, at least 1 degree. So I want to actually change everything now and adjust it so that my three components line up as well as possible. So I'm going to measure the angle of the prop shaft, then I'm going to measure the angle of the engine, change the engine to match that angle, and then I can adjust the differential to have the same angle there as well. At that point, all three components will be the same. I hope it makes sense, but that's what I want to achieve. Angle here, and angle here, exactly the same. I go through a suspension movement. Can you see what's happening? Only when I go into the suspension movement do I get a change of angle. I've got that angle looking at it from the top down in place already. So this change in angle combined with the top view angle will still only make one angle change, and I think everything will stay within parameters and the whole scenario will work. One way to find out. Let's do it. Okay, here's Mr. Kennedy on my prop shaft, courtesy of that magnetic base. Let's go closer to see what that angle is. Okay, I see 6.5 degrees. The engine angle, I'm going to put my meter against this nice flat face here of this front pulley, and I'm going to use an old-fashioned angle finder with a magnetic base. There you go. I've given up on those smartphone apps. I tried it here and I kept getting inconsistent results, so they were not accurate for me. I'm back to old technology. I'm measuring here currently, yes, you can call it 6 degrees. And then we come to pinion angle, that word that everybody likes to throw around. So what I did here is I've got this piece of aluminum angle bar. It's clamped against the face of the yoke, so I can use this as my line to take a measurement. So I'm just going to put my angle finder against the top part of this aluminum angle bar. There. I hope you guys can see. Okay, and I'm just waiting for it to stabilize. And as far as I can see, it's 8 degrees. So my pinion angle is a little bit more than the other two, about 2 degrees. So that would mean I would need to rotate the differential a little bit down to match them. So now my cradle here allows me to adjust this engine angle. I would like it to match the prop shaft angle, so I'm just going to adjust it here until they are the same. So I've got the spirit level lying across the tappet covers, so I need to turn each bolt the same amount to make sure that the engine remains level, if you know what I mean. As best as I can see, I'm sitting here at 6.5 degrees as well. So now engine angle is 6.5 and prop shaft angle is 6.5. So many sources say that engine angle should be between 3 and 5 degrees. So would that mean that I'm wrong? No, I don't think so. Actual engine angle is not that critical. It's much more important that the engine angle, pinion angle setup is done correctly. Many sources also say that your carburetor should be level and the engine angles should be adjusted accordingly. Well, my carburetor angle at the moment is 3.5 degrees. So what does that mean? Does it now mean that my engine is not going to work if I drive up this long steep incline or up a hill or a mountain for a long time? No, of course not. It's really not that critical in my mind. I think I'm happy with what's going on here. I've also got a sneaky feeling that the front of this truck is going to drop a little bit more, and then that will just get better. So that's what we've got so far. I've exaggerated the pinion angle just for the visual. So what I have to do now to line it all up perfectly, adjust the differential so that this 8 degrees also becomes 6.5. So yes, my perch brackets are not welded on yet, so I can actually still rotate the differential until I get to 6.5 degrees there as well, and then I've got perfect line up. Remember, I do have that 2.5 degree offset if you look at it from the top, which means undoing the U-bolts here just a little bit, and then I can push the diff down. I've got a jack there to stop it so it can't go too far, and I can always jack it up gently to get it, try and get it into its correct spot. Okay, it's a bit awkward to film here, but I'm going to try. So I managed to rotate the diff some. So currently you can see the angle is just a little bit more than 90. I've got the front of the differential sitting on my jack. So as I jack, it should change. Can you see the angle changing? What are we at now? From here it looks almost like 6. I must just check a little bit better. And you probably can't see it on the camera, but it's currently sitting at about 6 degrees. Awesome. Now I'm going to tighten my U-bolts again. No, I'm not. I was lying. I'm not going to tighten those U-bolts again. I'm first going to check my other angles one more time. The one here on the prop shaft, and then the one on the engine. So now I've got the pinion angle at 6.5 degrees as well. Awesome. 6.5, 6.5, 6.5. I've got good line up. Am I done? I've got a sneaky feeling I'm not, because there's one thing we need to keep in mind when we do all of this. The truck has to sit at ride height. Am I at ride height? The load bin is missing. That weight of the load bin. The weight of the front end, the nose, the body panels up there is still missing. So if we assume that those two weights are the same, it won't change much. But I've got a sneaky feeling that I'm still going to be messing with my front springs to drop the front of the truck a little bit more. What's going to happen if I mess with the front suspension and the front suspension drops while the back suspension stays where it is? Remember, I'm attached to the frame rail here. I'm attached to the frame rail here, so if I drop the front, that's going to happen. Not so. This is going to change now. These two angles will remain the same. Who knows what that might become, but let's just say for the argument it becomes 4. This one will also then be 4, because I'm attached at the engine mounting brackets. I'm attached here by the transmission. This movement, let's get rid of that. You know what I'm saying. So we might end up with something like that. So I'm not going to weld my spring bridge brackets yet. Only once I've got all my final weight in place and I'm at my happy ride height and happy with the stance, then I might want to just change that differential a little bit. And then I can finally weld those spring perch brackets. So now finally I can build my engine mounting brackets. Everything is now tuned up and measured and locked in place, and I've got little cradles holding it, engine angles, pinion angles, the whole journey. But now I can finally do these. I've got some clearance here between the manifold and the steering box. It's about 1/4 of an inch. I think that's acceptable. Awesome. You're still here. Thanks for staying with me on this journey through engine angles and lineups and pinions and all of that. Appreciate it. If you think you've learned something, please consider subscribing. If you think I've done something wrong, please let me know in the comments. So next up, I'll be building those engine mounting brackets. Finally, until then, stay safe and have a good one.